Hey there, physical science students. This is Miss Ruark. This is Vodcast 5.2. We're going to talk about phase changes or changes in matter and how energy plays a role. All right, so let's do a little review real quick. We know that physical properties are properties that can be observed without chemically changing matter or changing a substance. And we know that chemical properties describe how a substance will behave or react when it's mixed with other substances. So you have a list of physical and chemical properties, and we're going to put those, we're going to label them as physical or chemical properties. So your examples, you have color. Color should be, well, actually, I'll tell you what. How about you pause this, try them out yourself, and then unpause it and come back and check your work. All right, so physical properties, we've got color. Color is a physical property. Next one on your list is malleability. That would be the ability to pound something into thin sheets. So that would be a physical property. Corrosive talks about it being able to react with other things. So that's a chemical property. Acidity, chemical property. Texture, the feel of it, physical property. Ability to rust. The fact that it can rust is going to be a chemical property. Reactivity, chemical property. Solubility, physical property, because it's saying that it can actually dissolve in something. It's not saying that it's going to change into something new. It's just dissolving. Mass is going to be a physical property. Combustibility is a chemical property. Density is a physical property. And flammability, or the ability to go up in flames, would be a chemical property. All right, hopefully you did good. Okay, states of matter. So we know this is a review. Solids have definite shape, definite volume, and as far as the particles, they're tightly packed together, they're ordered, and guess what? Their movement, they're vibrating. All right, liquids, they have indefinite shape, they have a definite volume, the particles are close, they're not tightly packed and ordered, but they're close, and they're able to flow past each other. So they're moving, but they're not moving real fast. And gases have indefinite shape, indefinite volume. The particles are extremely spaced out, and they are moving so fast. All right, changes in matter. So physical change is a change in size, shape, or phase. It does not change the identity. It just changes how it looks. Chemical change is when one or more new substances are produced, and that's when you change the identity. All right, so phase changes, a change from solid, liquid, or gas is going to be a physical change. So you have a list of changes on your paper. Okay, go ahead and try these out, label if they think they're physical or chemical, and then come back and check your answers. All right, first one is tearing. We're just tearing a piece of paper. It's still paper. It's a physical change. The next one is grinding. Well, if you grind something down, you still have that substance. It's just in a powder form. So it's going to be a physical change. Crushing, same thing. And we're not talking about crushing on a boy or a girl. We're talking about crushing an object, such as a tin can. Okay, physical change. It's still a can. All right, combustion. Be able to go up, right? So that would be a chemical change. We're setting it on fire. All right, freezing. That's a state change. It's going from a liquid to a solid. So that's a physical change. Burning. If we were to burn a piece of paper, we don't have that paper anymore. We have ash now. So it's a chemical change. Melting, that's going from a solid to a liquid. It's still the same thing. So it is a physical change. All right, silver tarnishing. That's when silver gets that funky, like gray, cloudy look to it. And it's actually a chemical reaction because it's reacting with the oxygen in the air. So that would be chemical. Decomposing, it's breaking itself down. Okay? You don't want to eat a banana after it's decomposed. It's kind of gross. All right, so it's not the same thing anymore. It's a chemical change. All right, digestion, definite that doesn't look the same, so chemical change. And then breathing, you're breathing in oxygen and you're breathing out carbon dioxide, chemical change. All right, so temperature, we've already talked about temperature and energy first semester when we talked about energy and physical science. So let's do a recap on temperature. Remember that temperature is the measure of kinetic energy in a substance. Okay, it's measured in Celsius or Kelvin, and the kinetic energy of a substance, if it's a solid, those molecules are tightly packed together, so it's not going to have a lot of kinetic energy. It's going to have a very low kinetic energy. Okay, in a liquid, it's going to have a higher kinetic energy than a solid would because those molecules are able to flow past each other, but it's still not a high kinetic energy. A gas, on the other hand, those particles are spaced out and they are moving fast and they have a lot of kinetic energy. Okay, so just remember with the phase changes, solid is a low kinetic energy, gas is a high kinetic energy. All right, you also have two ways that you can describe a reaction. You can describe it in terms of energy. You have an exothermic reaction, which is when energy is being released. And an example of that would be burning wood. Okay, you not only see the energy that's being given off in the form of the light that's coming off, but you also feel the energy that's coming off in the form of heat. Okay, and then an endothermic reaction, an example of that would be melting ice. In order for the ice to melt, you have to put energy into it to break the bonds and make those molecules move a little bit faster. All right, phase changes in energy. So the phase changes that can happen. Freezing point is the point at which something starts to freeze. Okay, it's going from a liquid state to a solid state. Melting point is the point or the temperature at which something starts to melt, and it's going from a solid to a liquid. Okay, now those are two of the same things. They're just opposite of each other. So freezing point is actually going to be the same thing as melting point. Okay, so they're the same thing. They're just opposite of each other. Okay, boiling point is the temperature at which something starts to boil or change from a liquid to a gas. Condensation point would be the exact opposite. It's the point at which something starts to condense or change from a gas to a liquid. And condensation would be that stuff that's on your mirrors when you get out of the shower. And then the last one that's on here is sublimation point. And for sublimation, it's when something changes directly from a solid into a gas. And it does not change into the liquid phase. It goes directly from solid to gas. An example of that would be dry ice. Dry ice is used, it's changed from a solid. When you put it in water, it changes really quickly, but it goes from a solid to a gas, and people like to use it in witches' cauldrons and, to make smoke. Okay. And then the opposite of sublimation would be deposition, where it's going from a gas to a solid. Okay, so these are your phase changes in your energy. Well, in order to go from a liquid to a solid, you're going to have to lower the energy or remove the energy. Okay, and that would be an example of an exothermic reaction. Yeah, I know, it's weird, right? Yes. All right, melting point is going to be the exact opposite. You have to increase the energy, so that would be an endothermic reaction. Boiling point, going from a liquid to a gas, you have to increase the energy. It would be an endothermic reaction because you have to put energy into it. Condensation point or condensation would be a exothermic reaction because you have to remove that energy. And then sublimation, going from a solid to a gas, you would have to definitely increase that energy, and it would be an endothermic process. All right, and then the last part of this is we have the law of conservation of mass, and this is something that you need to be familiar with and you need to be aware of all through the chemistry portion of this class. Because the law of conservation of mass states that mass or matter cannot be created nor destroyed. Okay, so what does that mean? Well, that means that when we get to chemical reactions, whatever mass you have on your reactant side, you have to have the same mass on your product side. Okay, and saying it in different terms, the number of atoms that you have on your reactant side has to equal the number of atoms on your product side. You can't just pull atoms out of thin air, and you can't just toss them away like they're nothing. All right, and I think that's it. So I'll see you in class.